Hello and welcome. My name is Venukumar and I'm a senior software development engineer at Amazon. I'm excited to share with you today at Conf42 Kubernetes 2024 as we are going to explore the critical topic of securing the cloud through a multi-layered protection strategy and advanced threat detection techniques. As cloud computing continues to grow, with the market projected to reach 1.3 trillion by 2025, ensuring the security of cloud environments has become a top priority for modern enterprises. We'll talk about how organizations can protect their cloud-based data, infrastructure, and applications by implementing a comprehensive security framework. We'll dive deep into various layers of protection and discuss emerging trends and best practices to help you strengthen your cloud security posture. Let's move on to the table of contents, which provides an overview of the topics we'll be covering today. The agenda of our presentation today is as follows. First, we'll start with an introduction to cloud security and the growing significance of this area. Then we'll examine the key security challenges that organizations face as they migrate to cloud. From there, we'll take a deep dive into the multi-layer protection approach, exploring the various security layers, including network security, application security, data encryption, identity and access management, and endpoint protection. This comprehensive strategy is crucial for addressing the diverse threats and vulnerabilities present in cloud computing. We'll also discuss advanced threat detection methods such as behavioral analytics and real-time threat response that can help identify and mitigate sophisticated, previously unknown threats. Additionally, we'll cover proactive security measures, including continuous monitoring, vulnerability management that organizations can implement to stay ahead of evolving threats. To bring these concepts to life, we'll examine several case studies that showcase how leading companies have approached cloud security. Finally, we'll take a glimpse into the future trends in this rapidly evolving landscape, including the role of AI and quantum-resistant encryption. Let's begin by exploring the growing significance of cloud security and modern enterprises. As I mentioned, the cloud computing market is projected to reach 1.3 trillion by 2025, underscoring the critical need for robust security measures. As organizations continue to migrate their data, applications, and infrastructure to the cloud, new security challenges arise that require specialized strategies and tools. This rapid growth of cloud adoption has made cloud security a top priority for businesses of all sizes. Securing sensitive information, ensuring compliance with data protection regulations, and preventing unauthorized access to cloud resources have become essential to maintaining business continuity and safeguarding reputations. To effectively address these challenges, organizations must move beyond traditional security approaches and embrace a more comprehensive multi-layered protection strategy. This is the focus of our presentation today as we explore the various levels of security that are crucial for securing the cloud. Now let's dive into the specific security challenges that organizations face in cloud computing environments. The transition to the cloud introduces a range of security challenges that organizations must navigate. Some of the key challenges include data breaches, which can result from improper access controls or vulnerabilities in cloud-based applications and infrastructure. Insecure APIs, which can expose cloud resources to potential exploitation by attackers. Insider threats, where malicious actors bypass traditional security measures to access sensitive data and systems. Additionally, organizations must ensure compliance with data protection regulations such as GDPR and HIPAA, which can be particularly complex in the dynamic cloud environment. Understanding these challenges is crucial for developing effective security strategies and safeguarding your cloud-based operations. With this context in mind, let's now explore the multi-layered protection approach, which is designed to address these diverse threats and vulnerabilities. The multi-layer protection approach in cloud computing involves implementing security measures at various levels within the cloud environment. This holistic strategy ensures that if one layer of security is compromised, others remain intact to protect the system. The importance of a multi-layered security approach lies in its ability to address a wide range of threats, from data breaches and API vulnerabilities, which ensure against vulnerabilities like insider threats, complex challenges, etc. By combining multiple layers of protection, organizations create a comprehensive security framework that is difficult for attackers to penetrate. The key layers of protection we'll be discussing include network security, application security, data encryption, identity and access management, and endpoint protection. Each layer serves a specific purpose, working together to provide robust and resilient security for cloud-based resources. To better visualize how these layers work together, let's take a look at the flowchart that illustrates the flow of data through various security layers in a cloud environment. This flowchart demonstrates how data moves through the different security layers in a cloud environment. As data enters the cloud, it first encounters the network security layer, which controls and filters inbound-outbound traffic based on predefined security rules. The data then passes through the application security layer, where secure coding practices and vulnerability management measures are implemented to protect cloud-based applications from attacks. Next, the data encryption layer ensures the confidentiality and integrity of the information, both at rest and in transit as well, through the use of encryption standards and robust key management practices. Also, the identity and access management is responsible for controlling who can access cloud resources and under what conditions, helping to prevent unauthorized access and ensures accountability. Finally, the endpoint protection layer safeguards the devices such as laptops, mobile phones, and desktops that connect to the cloud, as these can be common attack vectors. Each of these layers play a critical role in providing comprehensive protection for data as it moves through the cloud infrastructure, ensuring a resilient and secure environment. Let's now dive deeper into the network security layer, which forms the foundation of this multi-layered approach. The network security layer is the foundation of any multi-layered security strategy in the cloud. This layer focuses on protecting the perimeter of the cloud environment, preventing unauthorized access, and safeguarding sensitive data as it moves across the network. Key components of the network security layer include firewalls, intrusion detection systems, intrusion prevention systems, and distributed denial of service protection. These tools work together to monitor network traffic, detect and block suspicious activity, and ensure the availability of cloud-based services. We'll start by discussing firewalls and their role in network security. Firewalls are a crucial component of the network security layer, acting as a barrier between trusted and untrusted networks. These security devices control inbound and outbound network traffic based on predefined rules, allowing only authorized traffic to pass through. In the context of cloud computing, firewalls can be configured to protect virtual networks and control access to cloud resources. By carefully defining and implementing firewall rules, organizations can prevent unauthorized access to sensitive data and cloud-based infrastructure. Firewalls play a vital role in creating a secure perimeter around the cloud environment, ensuring that only legitimate traffic is able to enter or exit the system. This helps to mitigate a wide range of threats, from network-based attacks to data breaches. Next, let's see how next-generation firewalls enhance traditional firewall capabilities. Next-generation firewalls take the capabilities of traditional firewalls to the next level. They provide deep packet inspection, application awareness, advanced threat detection features, offering more granular control and enhanced protection against evolving threats. The effective implementation of firewalls, whether traditional or next generation, is a critical foundation for any multi-layered cloud security strategy. Let's now turn our attention to the intrusion detection and prevention systems that complement the firewall layer. Intrusion detection systems and intrusion prevention systems are essential components of the network security layer in cloud environments. These systems work together to continuously monitor network traffic for signs of suspicious activity and take immediate actions to mitigate threats. Ideal solutions analyze network traffic patterns that detect deviation from normal behavior, which could indicate the presence of malicious activity. When an IDS identifies a potential threat, it generates an alert, allowing security teams to investigate and respond accordingly. IPS systems take the next step by actively intervening to block or prevent detected threats. These systems can automatically take actions such as stopping or rerouting malicious traffic to stop the attack from causing further damage. The combination of IDS and IPS provides a robust defense against a wide range of network-based threats, including unauthorized access attempts, malware propagation, and denial of service attacks. By continuously monitoring and responding to threats in real time, these systems play a crucial role in protecting the cloud environment. Alongside firewalls and other network security measures, IDS and IPS solutions form a layered defense that helps organizations detect, prevent, and mitigate security incidents, ensuring the overall resilience of their cloud infrastructure. Let's now explore another critical component of the network security layer, DDoS protection. Distributed denial of service attacks pose a significant threat to cloud environments, as they can overwhelm systems with malicious traffic and disrupt the availability of critical cloud-based services. DDoS protection systems are designed to mitigate these type of attacks by filtering out and observing the malicious traffic, ensuring that legitimate users can continue to access cloud resources without disruption. In the cloud context, DDoS protection is often integrated directly into the cloud provider's infrastructure, providing comprehensive defense against these type of attacks. Cloud providers employ specialized tools and techniques to detect, analyze, and automatically respond to DDoS threats in real time, helping to maintain the availability and reliability of cloud-based services. By implementing DDoS protection as part of the network security layer, organizations can safeguard their cloud environments from the potentially devastating effects of these attacks. This further strengthens the overall security posture and ensures the continued operation of critical cloud-based applications and data storage. The seamless integration of DDoS protection into the cloud infrastructure is a key benefit that cloud users can leverage to enhance the security and resilience of their cloud-based operations. Next, we'll explore how VPNs provide secure access to cloud environments. Virtual private networks, VPNs, data traffic between users and cloud environments, preventing eavesdropping and ensuring secure access to sensitive cloud resources. Now that we have covered the foundational network security layer, let's move on to the application security layer and the measures taken to protect cloud-based applications. The application security layer focuses on securing the cloud-based applications that are hosted and accessed within the cloud environment. Cloud-based applications can be vulnerable to a wide range of attacks, including SQL injection, cross-site scripting, and other application-level vulnerabilities. Securing the application layer involves implementing secure coding practices and maintaining a robust software development lifecycle. This includes regular security reviews, vulnerability assessments, and the application of security patches and updates to address known vulnerabilities. Application security testing such as penetration testing, vulnerability scanning, plays a crucial role in identifying and remediating security weaknesses before they can be exploited by attackers. By proactively addressing application-level vulnerabilities, organizations can significantly reduce the risk of successful attacks on their cloud-based applications. Let's delve deeper into the importance of patch management in application security. Regular patching is essential for addressing known vulnerabilities in cloud applications. Patch management systems help automate the process of updating cloud-based applications with the latest security patches, ensuring that known vulnerabilities are addressed in a timely manner. This helps prevent attackers from exploiting these weaknesses to gain unauthorized access or compromise sensitive data. Next, we'll discuss the role of application testing and vulnerability scanning in maintaining secure applications. Application security testing such as penetration testing and vulnerability scanning plays a crucial role in identifying and remediating security weaknesses before they can be exploited by attackers. By proactively addressing application-level vulnerabilities, organizations can significantly reduce the risk of successful attacks on their cloud-based applications. The application security layer works in tandem with the network security layer to provide a comprehensive defense against a diverse range of threats targeting cloud-based applications. Maintaining the security of these applications is crucial for protecting the overall integrity of the cloud environment. Let's now turn our attention to the data encryption layer, which plays a critical role in safeguarding sensitive information in the cloud. Encryption is a fundamental layer of protection in the multi-layered security approach for cloud environments. By transforming data into a unreadable format, encryption helps ensure the confidentiality and integrity of information, both at rest and in transit. Now let's take a look at encryption at rest. Try to understand that. Encryption at rest secures data stored in cloud databases and storage systems using strong encryption standards like AES-256, ensuring that even if storage systems are compromised, the data remains protected. Next, we'll cover encryption in transit and how it protects data during transmission. Encryption in transit protects data as it moves from different cloud services or across the internet. TLS is commonly used to secure data transmitted on networks, preventing interception by malicious actors. Let's discuss the key management. Effective key management is essential for securing encrypted data. It includes generating, storing, and rotating encryption keys securely to prevent unauthorized access. Proper key management ensures the overall integrity of encrypted data. The data encryption layer combined with the network and application security layers forms a powerful defense against a wide range of threats targeting sensitive information in the cloud. Let's now explore the identity and access management layer, which is responsible for controlling who can access cloud resources and under what conditions. IAM systems, meaning identity and access management systems, manage user identities and control access to cloud resources. These systems enforce security policies to ensure that only authorized users have access to sensitive data and applications. Let's look at the usual roles and permissions we need within identity and access management systems. User roles and permissions allow organizations to implement least privilege access, ensuring that users only have access to the resources necessary for their job functions, reducing the risk of unauthorized access. Next, we'll look into multi-factor authentication and its role in cloud security. Multi-factor authentication adds an additional layer of security by requiring users to provide multiple forms of verification before accessing cloud resources, which reduces the risk of credential theft. Implementing multi-factor authentication helps protect against credential theft and ensures that compromised credentials cannot be used to access cloud resources. Next, we'll move on to endpoint protection, which is critical for securing devices connected to cloud environments. Endpoints such as laptops, mobile devices are often targeted by attackers. Endpoint protection solutions safeguard these devices from malware and unauthorized access, helping to protect cloud environments. Mobile device management helps secure mobile endpoints. In particular, let's take a look at that. Mobile device management system helps secure mobile endpoints by enforcing security policies and managing applications. These systems allow organizations to remotely manage and secure mobile devices accessing cloud environments. We have endpoint detection and response systems monitoring and protecting endpoints. We'll take a look at that. Endpoint detection and response systems provide real-time monitoring and analysis of endpoint activity. This helps detect malicious behavior, allowing organizations to respond quickly to security incidents before they spread to cloud environments. Having looked at the endpoint protections and mobile device management and endpoint detection and responses, next we'll explore advanced threat detection techniques in cloud environments. Advanced threat detection systems use behavioral analytics, machine learning, and AI to identify patterns and anomalies in real time, allowing organizations to detect and neutralize advanced threats before they cause damage. Advanced threats such as zero-day attacks require sophisticated detection techniques. Modern systems use machine learning, artificial intelligence, and behavioral analytics to detect patterns and anomalies, allowing real-time threat detection and response. Next, Let's dive deeper into how behavior analytics help detect insider threats. Behavioral analytics tools monitor user interactions with cloud resources, identifying deviations from normal behavior. These tools are especially useful for detecting insider threats for account takeovers. Let's now take a look at real-time threat response and how it reduces the impact of cyber attacks. Real-time threat detection systems allow organizations to respond to threats as they happen. Automated systems can block malicious activity and isolated compromised accounts, minimizing damage and reducing response times. Moving ahead, let's explore the importance of proactive security measures. In addition to a multi-layered protection strategy, organizations can adopt a range of proactive security measures to stay ahead of evolving threats in the cloud. These measures focus on continuous monitoring, vulnerability management, and other proactive steps to prevent security incidents before they can occur. Vulnerability management is another key proactive measure involving the regular assessment of cloud-based applications, infrastructure, and services for known vulnerabilities. By addressing these vulnerabilities through patching and remediation, organizations can minimize the risk of successful attacks. Continuous audits and monitoring of the cloud environment are crucial for identifying security gaps and ensuring that security configurations are up to date and compliant with industry standards. By continuously monitoring the cloud infrastructure, organizations can quickly detect and address any potential vulnerabilities or anomalies. These proactive security measures, combined with the multi-layered protection strategy, help organizations maintain a strong security posture and stay ahead of evolving threats in the dynamic cloud environments. To illustrate the practical applications of these concepts, let's examine a few case studies that showcase how leading organizations have approached cloud security. Let's talk about Netflix. Netflix uses a multi-layered security strategy, like employing custom tools like SecurityMonkey. They do that to monitor cloud environments. This proactive approach of theirs ensures proper security measures are used. They use regular security testing and continuous monitoring so that they are always up to date. Automation plays a key role in Netflix's cloud security, allowing them to detect and respond to threats faster. We'll look at another example. So in 2019, Capital One had a data breach which resulted in the exposure of personal information of over 100 million people. The breach was primarily caused by a misconfigured firewall and weak access controls, which allowed an attacker to access sensitive data. This case highlights the critical importance of proper configuration and robust access controls in cloud security environments. It underscores the vulnerabilities that can arise from seemingly minor oversights and the catastrophic consequences they can have. Now let's transition to discussing the importance of ongoing security measures and best practices that can be derived from these case studies. Based on the concept and case studies we have explored, there are several best practices that organizations should consider to strengthen their cloud security posture. Regularly conduct security audits, vulnerability assessments, and penetration testing to identify and address security gaps in the cloud environment. Implement a patch management system to ensure that cloud-based applications and infrastructure are kept to date with the latest security patches and updates. Adopt a zero trust model where no user or device is automatically trusted, and implement robust access controls and multi-factor authentication. Continuously monitor the cloud environment for security incidents, anomalies, and compliance issues, and respond quickly to mitigate potential threats. Stay informed about the latest security threats, trends, and best practices to ensure that your cloud security strategy remains effective in the face of evolving challenges. By following these recommended practices, organizations can build a comprehensive, resilient, and proactive cloud security framework that is well equipped to address the diverse threats and vulnerabilities present in the dynamic cloud computing landscape. As we move towards the conclusion of our presentation, let's now explore some of the future trends that will shape the cloud security landscape. As the cloud computing industry continues to evolve, several emerging trends are poised to have a significant impact on the future of cloud security. Two key trends that deserve close attention are the growing integration of artificial intelligence and machine learning in cloud security solutions. AI and ML-powered systems can analyze vast amounts of data, detect anomalies, and automate threat response, enabling organizations to identify and mitigate sophisticated, previously unknown threats in real time. The need to prepare for the potential threat posed by quantum computing to current encryption methods becomes important. As quantum computing capabilities advance, there is a growing need for organizations to adopt quantum-resistant encryption algorithms such as lattice-based cryptography to ensure the long-term security of data stored and transmitted in the cloud. By staying informed about these and other emerging trends, organizations can adapt their cloud security strategies and ensure that they are equipped to address future challenges. Proactively addressing these trends will be crucial for maintaining a secure and resilient cloud environment in the years to come. Let's now summarize the key takeaways from our discussion on security in the cloud. In summary, the key takeaways from our presentation on security in the cloud include the importance of a comprehensive multi-layered security approach that combines network security, application security, data encryption, identity and access management, and endpoint protection. The critical role that each security layer plays in providing robust and resilient protection for cloud-based resources, ensuring that if one layer is compromised, others remain intact. The value of proactive security measures such as continuous monitoring and vulnerability management in staying ahead of evolving threats and preventing security incidents. They need to stay informed about emerging trends such as integration of AI/ML and the threat of quantum computing to ensure that your cloud security strategy remains effective in the long term. By implementing a multi-layered protection strategy and adopting a proactive, forward-looking approach to cloud security, organizations can effectively safeguard their cloud environments and the sensitive data and resources they host. In conclusion, securing the cloud is an ongoing process that requires constant vigilance, adaptation, and a comprehensive security strategy. As cloud computing continues to grow and evolve, organizations must be prepared to address the diverse and ever-changing threats that target their cloud-based environments. By embracing a multi-layer protection approach, integrating advanced threat detection techniques, and implementing proactive security measures, organizations can build a robust and resilient cloud security framework. Staying informed about emerging trends such as the role of AI and the implications of quantum computing will also be crucial for maintaining the long-term cloud security. The case studies here examined demonstrate that leading organizations are already applying these principles to protect their cloud-based data, applications, and infrastructure. By learning from these examples and adopting best practices, your organization can enhance its cloud security posture and ensure the continued success and growth of your cloud-based operations. Finally, thank you for the opportunity.